Hello, my name is Kory. I'm a senior electrical engineering technology major here at Alfred State College, and for my senior project, I decided to create an electric longboard. Now, this design originally stemmed from a YouTuber named Jehu Garcia, who specializes in hobby electronics, and he came up with the idea of using hoverboard wheels instead of regular hub motors to power an electric skateboard on a budget. Now, this is his base design, and this is the schematic that went off for most of the project. However, it was lacking mandatory necessary features such as a built-in charger and just easy ways to access the board itself. So I decided to upgrade this and take my own spin on this design. So for this board right here, I ended up having a battery life of about 1 hour, and that's mainly due to having 4 motors. The 4 motors just eat through the battery like there's no tomorrow. I also have a recharge speed of about 4 hours. If you zero the batteries out completely dead, it'll take about 5, but I normally leave about 10% left in the batteries just to be safe. So it takes around 4 hours. It has a top speed of 15 miles per hour in the high setting. So there's 2 settings on it. On the remote, there's a low and a high setting. So in the low setting, it'll keep you at about 267 RPMs. And in the high setting, the top that you can get is 700 RPMs. And due to these massive 6.5-inch motors and having 4 of them, has enough power and torque to be able to pull a person up roughly a 15-degree incline. When I originally estimated out this project, I wanted to spend under $650. I left myself some wiggle room, and when I started and did this presentation back in December, I estimated it to be $598.74. However, my actual cost analysis came out to be $665.48. The main reason for that is at the beginning of the project, I decided that I was going to try to build my own battery charger. However, doing some research, I found out how volatile lithium-ion cells were. So I opted just to buy one instead and to save time and my own face in case of an explosion. I also saved some money around the whole budget. On the board, I saved about $40, and on the batteries, I saved about $60. So I had a little bit of give and take. Also, one of the things that added up really quick was the connectors for the wires, as well as the mounting hardware to keep everything intact on the board. Now, as I mentioned at the beginning, these motors are 6.5-inch hoverboard motors, which are off of a hoverboard, which is a self-balancing unicycle. They're 6.5 inches in diameter, and they are brushless hub motors. They have an amazing feature of regenerative braking. So when the motor is not engaged and you're going down the hill, the battery will recharge, and you can actually watch the battery meter tick back up from the wheels just freely spinning and generating electricity. Now, these come stock in a Y configuration from the factory, which gives you plenty of low-end torque for when you originally start. There's no lag at all. It just picks right up and goes. Now, to power this board, I decided to use lithium-ion 18650 cells. They're 4.2 volts per cell, and I got these from a used eBay distributor who recycles them out of laptop batteries. The ones that I wanted were 2200 milliamp hour batteries. However, what I ended up going with was a cheaper option of getting 1400 to 1600 milliamp hour batteries. One of the main issues I had was because they had that 200 milliamp hour gap of it could be 1400 milliamp hours or it could be 1600 milliamp hours. When it came to calibrating the kilometer, I had to go and set the top battery capacity at 1400 milliamp hours just in case. That way, if it died when you were out riding, you wouldn't be upset that you all of a sudden you thought you had more time, but it just died on you. So I gave that 200 milliamp hour wiggle room as a safety precaution. Now, the way I use these batteries is that I have 10 battery packs on the board. Each battery pack contains 4 4.2 volt cells wired in parallel to create one large 4.2 volt cell. And then I have 10 of them wired in series to create a 42 volt system, and they're connected by little tin pieces. For this project, when I started, my original design, I wanted a 10+ mile range. I also wanted a minimum of 10 miles an hour as a base point for how fast I'd like to get over. I wanted a board that was 36 to 42 inches in length, as well as it weighing under 30 pounds. And I wanted it to be easy to recharge, because nothing is more frustrating than sitting there trying to use your electronic device and you can't use it because the charger's all messed up, or the ports don't work, or anything that would just not line up. I wanted it to be simple. One plug would go into the board and you'd be set. And I also wanted it to cost something $650. By the time I finished this project, I ended up getting about a 7-mile range. And that is due largely to the fact that I used 4 of these motors. I didn't realize how quickly they would eat through those 1,400 to 1,600 milliamp hour batteries. I also only got a maximum speed of 15 miles an hour. Again, that's due to just these motors, just having 4 of them eat through the power too quick. I think if I redistributed the power effectively and overvolted the motors slightly, I could get a little bit faster, but 15 is the max that I achieved. I went with a 41-inch deck. This deck was made by Original Skateboards. It's 9-ply maple, and it's 41 inches in length. This deck was made for heavy riders, such as people up to 250 pounds, so it was a perfect project board because I knew I could rely on it without it snapping midway through the project. I also achieved one singular XLR charge port, so it's a 3-prong clip that goes right into the top of the board, and it has a latch on it and a lock, so if the wire gets pulled or something like that, it's not going to pull out of the charger. It's going to be right in there, so you know it's charging 100% of the time. The charger also has a red and green light, so when it's charging, it gives you a red light, and when it's fully charged, it gives you a green light, as well as the battery coulombor on top of the board. And for this project, as I mentioned at the beginning, I ended up spending $665.48, which is slightly over budget, but I'm okay with that. A little bit of $15 is nothing to really roll your eyes at. So this is the completed bottom of the board. It looks like a rat's nest, but it's really not that complex. Here's my battery cells, and then I have my battery management system, which actively measures the voltage in between each of the cells and redistributes the voltage if there's not enough going to one cell or too much going to another. And if it has an error, it shuts down and doesn't allow any more voltage into the cells for a safety precaution. I also added a one-touch reset switch here. The board has a master-slave driver circuit that goes to it, and in order to bypass the digital fuse, say you trip it when you give it too much throttle right at the beginning, you can just tap that and cut all the power off, and it resets that digital fuse, and you're ready to go again. And the board, one of the main designs I wanted was a modular design, so it's very simple and very easy to work on. I use regular hose clamps, so if you wanted to take out one battery pack, so you're having issues with this pack, you take a screw out here, and unscrew the hose clamp, slide the pack out, take your replacement pack, slide it back in, tighten the 3 screws, and you're ready to go again. So it's very simple and very easy to work on. Possible upgrades for this, I would rebuild this with 2 instead of 4 hub motors. The 4 hub motors eat through too much power. I believe a 2 motor in the rear and 2 regular unmotorized wheels in the front would be the perfect build. It wouldn't eat through your power as much, and I believe it would actually give you a little bit faster speed due to the weight reduction as well as the power consumption. You could also rewire these motors into a delta configuration to get a higher top speed. You get a 1.3 times higher top speed if you were to do that. For this project, I had a couple issues. The batteries were a huge issue for about a month. I had dead cells. I had charger issues of where the charger wouldn't read because I had the dead cells. I also accidentally shorted a battery management system due to the fact of just the Chinese schematics were very hard to read. And also the vibrations breaking my solder joints just from the rough conditions of the road. All in all, I really worked through all the troubleshooting. It was not that terrible. I didn't have any major malfunctions besides that battery management system, so it was really a solid project. These are the works cited that I have that I use to create all of my data and to get all of my schematics. I'm very proud of this project. I feel like it lived up to the standards, and I hope that it lived up to your standards as well. Thank you for listening to this project, and have a great day.